train wrecks in your code. That's not a good thing, right? So what can you do to prevent your modules from banging into one another and coming off the rails like a train of carriages? Okay, I'm actually talking about coupling. Unnecessary coupling is one of the two great scourges of software design, along with poor cohesion. And sometimes unnecessary coupling is kind of easy to spot and relatively straightforward to fix. In this session, we'll learn the Law of Demeter and what it's useful for. This is a guided learning hour, and that means this is a training designed to be done together with the other people in your development team. You'll learn software development skills and get experience with new tools and techniques. And these are skills that your team should be able to take advantage of in your daily work afterwards. You'll get much better results if you all take part in these sessions and support one another. And I can pretty much guarantee it'll be more fun than doing it by yourself. If you haven't done one of these before, please check out my video, Guided Learning Hour How To. The last section of this video is the briefing for the facilitator, the person who'll lead the session. There are also more materials available to my Patreon subscribers. When you're ready to begin, pause the video and gather your team. Let's start the learning hour. Hello everyone, I'm Emily Bache. Today's session is about the Law of Demeter. We're using this shared online whiteboard that everyone should have access to. To begin with today, I've got a couple of little code samples for you to look at. This is the first one, and I think if you read this, you might have some concerns about the design. So when you've come up with something, perhaps reveal the follow-up question. It's underneath that little note. And then take a look at the second piece of code as well. This has another potential design problem. What are your concerns reading this code? And then when you discuss that, you can reveal the follow-up question as well. So just spend a few minutes now doing that all together. I hope you had a good discussion and that the topic of encapsulation wasn't totally new to you. We've got a bit of a problem with encapsulation here. This set method on the account balance property means that anyone from outside this class could potentially come in and change the amount of money in the bank account, which might not be a good thing. So this is an encapsulation problem. In this next example, it's not so much an encapsulation problem as a coupling problem. So the cash machine class knows about the branch finder, but from there it gets the branch, and then from there it gets the personal accounts manager, and from there it gets the bank account, and then it can go and withdraw some money, which means that this cash machine has a coupling problem actually. It's coupled to all of those other classes and knows about what methods they have. Actually, this might not be a problem, but it's definitely something you'd want to kind of look into, whether you could do it in a better way. So on this picture here, I've got the same code snippet, but this time I've drawn a box for each of the objects involved here. And this means I can actually now draw the dependency arrows between them. So the cash machine knows about the branch finder, has a property, which is the branch finder. And from there, we can get the branch. From the branch, we can get the personal accounts manager. From the personal accounts manager, we can get the bank account, and then we can actually withdraw some cash. So that wouldn't be so bad, but the problem is the cash machine also, because the way we've got all this code in the same class, it knows about all the other classes in this message chain, all the other objects. So this, these red arrows I'm drawing now represent the dependencies or the coupling from the cash machine to all these other objects. And it's these red ones which are potentially the problem. Another way of talking about bad coupling is to say that it's not following the Law of Demeter. Now, the Law of Demeter is a kind of a fancy name for something which somebody came up with in, I think, the 80s. And the gist of it is your class should talk to its friends, not a friend's friends. There's a bigger definition and more explanation on Wikipedia if you want to check out the details. Some people also say, oh, it's just avoid train wrecks. This is a train wreck. We've got a coupling problem. This object is coupled to all these others. We've got this message chain. It's also known as the principle of least knowledge. If you don't need to know about those other classes, then you shouldn't. That should all be encapsulated behind a nice interface. So that's where we get this. The design principles here are to do with we need encapsulation and not so much coupling. So according to Demeter, there are 4 kinds of friend. There are method parameters, there are class parameters, locally created objects, and global data. Those are all your friends that it's okay to talk to. But if you find yourself talking to other things, those are friends of friends, that would be more of a problem. Just a small note here about global data. Avoid that if possible, particularly if it's mutable. Global data is everybody's friend, and you can run into difficulties with that. Okay, so now I've got some hands-on for you to do together. So this is 4 little exercises that I've got, and each one looks the same. Let me just zoom out a bit on the board. You can see I've got these 4 exercises here. Each one has a snippet of code, and some of the code has a green box around it. And it's in that green box I really want you to look and see if you can find any problems with the Law of Demeter. So to help you here, I've got boxes for you to draw the object dependency graph, and you can mark dependencies that are problematic with a red arrow. And then I've also got this little hand symbol, and you can move this onto the code and to show in the green box, which is the friend class that you're allowed to talk to. And anything else is a potential problem with Demeter. But it's good to be able to spot which is the friend. So this is the first example. The second one is pretty similar. The third one here has got slightly more classes, more objects that you need to draw a dependency graph. And this last one has just got a bit more code, but only 2 kinds of object. So pause the video now and see if you can do those 4 object graphs. Great, so let's just go through what I had on these ones. You might not have exactly the same thing, but I think the most important thing is you've had a good discussion about this. So on this first example, I've put the hands on the friend class, which is the customer. The newspaper delivery service has a method argument, the customer, so that's a friend. But the problem is we then ask the friend for their wallet, and then we take money out of it. So that's the problematic dependency for Law of Demeter. The second example looks kind of similar. We've got the magazine delivery service instead of the newspaper delivery, and the customer is still the friend class here. But in this one, we actually don't know about the wallet. That's encapsulated behind the customer.requestPayment method. So this design doesn't infringe on the Law of Demeter. This next example here, a few more classes, and we've really got some problems here. We've definitely got a bit of a message chain going on here. The car class has a friend, which is the engine, but it's also talking to the fuel system and the fuel pump. Those details are perhaps, we don't want to be coupled to all those details. And the fourth example here, we've also got a message chain here. So we've got the dot with name, dot with age, with street address. So it looks superficially like we could have a Demeter problem, but actually when you look at the object dependency, these 2 classes are both friends with each other, so there's actually no problem. The person builder is returning instances of itself from all these methods. So this is actually not a Demeter problem here. So it's one of the things you should watch out for. A message chain is often a sign that there is a problem, but not necessarily. You need to delve a bit deeper to work out if it really is. This code we just looked at definitely has a problem with the Law of Demeter. I'm going to show you now how we can sort that out quickly and relatively safely using a modern IDE and good tools. The demo is of Rider and ReSharper in C#. But try not to get too hung up on the details of the programming language. Focus on what's important about refactoring, taking small, safe steps and using tools effectively. So this is something of a contrived example, but I hopefully will be able to look at how to solve a Demeter problem here. So this is our message chain, and this is I'm just going to highlight the whole thing and try and extract it as a method. And when I do that, I'm looking at the kind of signature that it proposes for me, and I'm thinking this isn't quite what I want, because my aim with extracting this method is that I'm going to move it to my friend class. So I will solve the problem. And the easiest way to do that is if the friend class is one of the arguments, and the friend here is branch finder and it's not appearing there. So I'm going to just abandon this, and I'm going to do a little trick that I found very helpful for this. Extract a variable or introduce a variable for the friend first, and then when I do the same thing again and highlight this whole piece of code and do the extract method, it will actually propose the branch finder as one of the arguments. You see it's on the list there. And that's going to make it easier to move that class there in a minute. So I need to name this new method, and I'm going to call it withdraw, the same as the original method, because that's still what it does. And I'm going to make it public to make it easier to move. So there's my new method, and I'm going to now move that to the friend class. And I just need to type in the name. Great, so that's looking a little better. So if I go over to the new home for my class, this is still static, and it should actually be an instance method. So I'm going to make it non-static. And then I have to choose which instance to make it not static on, which is of course that argument that I added earlier. So this is my method in its new home. And now that little variable that I extracted earlier, I can just inline that. So this is kind of looking okay, but I've moved the stuff into branch finder, my friend, which means I no longer have a message chain here. But it's a little bit strange actually to have that functionality on a class called branch finder. So I'm kind of thinking that I've just increased the responsibilities of this class. It's now kind of providing some kind of facade or access to all of the account functionality, perhaps, or at least the withdraw functionality. So I think I'm going to actually rename this class to reflect its new responsibilities. I'm going to call it account access. And now I think that, it's just got this little dialogue that came up. Are you sure? Rename related symbols? Yeah, fine, great. Do that for me. Thank you. And now I think it looks a little bit better. I've got this cache machine is using an account access to withdraw stuff, and it doesn't know about all those other objects. But now, of course, I've pushed the problem down into account access. Here I've got still a message chain. It's a bit shorter, but this is a constructed example. I want you to practice this. I want you to do this several times, pushing the stuff down to the message chain. So again, create the little variable for the friend class, then select all the message chain, extract a method, make sure that one of the arguments is the friend class that you want to move it to in a minute. That's the branch. So that looks good. And again, I'm just going to name this withdraw. That's what it does still. It's withdrawing some money. And now with this new method being here is the wrong place for it, I'm going to move it to the branch. Yep, moving this to the branch. And again, it prompts me now, oh, you forgot to make it public. Yeah, it needs to be public to be moved. Great, fine. But now I can make it non-static on the branch. And again, that's looking a bit better. Shorter message chain in the right place. And this class is only talking to its friend. I don't think I need to inline that variable. Branch actually is quite a good variable. But now I've moved the problem here. Okay, so we're doing it all again. And I might just leave this for you to fix. It's the same thing. You extract a method. I forgot. I need to first extract the variable for the friend so that it makes sure that that's in the list of arguments. When I do the extract method, let's try that again. Okay, here we go. Now we've got the right arguments. Let's name the method and let's move it onto the friend class. And again, it prompts me, I forgot to make it public. It's just, it can fix that for me, so that's good. So here we go. I'm just going to make it non-static on the personal accounts manager. So now the message chain, much shorter. And here I think I'll inline that variable again. So here, just talking to the friends, no message chain. If I go down into here though, again, that's just talking to friends. Bank account is a friend here. So I think I'm done. Okay, so now it's your turn. Open up this code in your best refactoring IDE and see if you can identify the friend object and then extract a method that you can then move to the friend. And you can do that several times in this problem. It's time now just to stop coding and do the conclusions activity. So I'd like you each just to reflect on what happened today and what you learnt about the Law of Demeter, and just write a note so you remember it. Each person individually write your own note in your own words, and so you can remember what is this and what should you look for. So when you're coding today, keep an extra eye out for Law of Demeter problems. If you spot one, it could be a refactoring opportunity. Whatever you choose to do about it, remember, work in small steps and use your tools. If you liked this session, please hit like and tell your friends about it. Happy coding! This part of the session is for the facilitator, for you to do a bit of preparation before you lead this session with your team. And the first bit of preparation I want you to do is to pause the video now and note down for yourself, what are the things that you think you need to do before you would lead this session? Your list is always going to be better than anything I come up with. So do that first. Okay, now hopefully you've got some notes like this on your version of this frame. So I'm imagining that you're going to need to set up the code for the exercise in a project, and it might be good to just check that and make sure you've got it to compile and you can run and the code compiles. There aren't any tests for this one. Another thing you might want to do is, before you do the exercise, how can you draw arrows on your activity board so that you can draw those dependency diagrams? And the other thing is that the first couple of questions are about encapsulation and coupling. And it might be good if you just read up on that beforehand so that you know yourself what those things are, in case people are unsure in the session and you can explain them. But hopefully people already know what those things are. And just reminding yourself could be a wise move though. When it comes to actually doing the session with your team, there are 4 activities that you need to facilitate. So the first one is the connect that we just talked about. There's also this little exercise you're going to do all together. The concrete practice, that's the coding exercise, and then a short conclusions. So one of your jobs is to keep time and make sure the session doesn't overrun. So this is a guideline. If you need more or less time than that, then adjust as you need. So the connect is these 2 little code samples to review. And if they're not getting it, if they're not spotting the encapsulation problem or the coupling problem, you could give hints. You could say, have you seen there's a setter on the account balance? You know, that kind of thing. And then when you think they've actually started to identify the problem in the code, you need to reveal the follow-up question. And hopefully somebody will say, oh yeah, that's an encapsulation problem, or, you know, and if they don't get it still, you can basically tell them, but don't tell them straight away. Let the group see if they can come up with something. This is about your team talking about code together and design. So it's important that you're there kind of being friendly and helping people to talk. The next part is, again, it's getting people to talk about design. And I'd like you to try doing this all together on the 4 code samples. So you put your code up on your screen where everyone can see it and control the mouse and draw the diagram. But don't just do it for them. Of course, you've got to ask people, what should I draw? What's the problem here? Different people take different amounts of time to read code. So don't be afraid of just giving everyone a few minutes in silence just to read the code before you ask anything. If the group is very large, you could split into smaller groups. Just take copies of the frames and go into breakout rooms. And then there's the coding exercise. There could be a couple of problems here. Perhaps it's difficult to get the initial code working. Hopefully you'll have done some preparation. You'll be able to help people with that. The other thing that could happen is that your refactoring tools don't work the same as mine, or whichever programming language you're using doesn't have the same kinds of refactorings. So that also might be good for you to have done a bit of preparation there and just tried it out. Can you do move method in your tools? And if not, what's a safe way of doing that? Can you, you might not get as far in the exercise if you don't have such good tools, but again, focus, small, safe steps. So work in pairs for this part if possible, unless you think that it would be better to do it all together in one group with you showing people on your screen. Both of those options are good ones. And then there's the conclusions. This should just be a few minutes at the end. It shouldn't take people long just to write a note with their understanding of what this session has been about and what they want to remember from it. And you don't need to say anything about what they've written. It's just really for them. And if they don't write anything, well, you know, it's only a couple of minutes of time. Okay, so I wish you all the best leading this session with your team. You could even let me know how it goes in a comment.